Hi everyone. Today we are going to be learning lesson 10-9. So I'd like you to take a minute to read through the do now. The voltage used by most households can be modeled by a sine function. The maximum voltage is 120 volts and there are 60 cycles every second. What equation best represents the value of the voltage as it flows through the electric wires where T is time in seconds? So please take a few minutes to try to answer the do now question. Pause the video and check your answer when you've come up with your choice. Okay, so let's go over the do now question. So they tell you that the maximum voltage is 120 and you're talking about a sine function. So the fact that the maximum voltage is 120 is really telling you that the amplitude of your function is 120. But if you notice, if you look at your four choices, that's not going to help you narrow down your answer because all four have an amplitude of 120. So this is really telling me my amplitude. So if you look at your four choices, the real difference here is what the frequency is. So the frequency is the number in front of the T. So I'm going to look at all four of my frequencies. This one would have a frequency of 1. This would have a frequency of 60. This one is 60 pi, and this one is 120 pi. And I want to try to figure out which one is correct. So notice they don't tell me the frequency in the question, but they do tell me that there are, I'm just going to make this a little bit bigger, there are 60 cycles in 1 second. Okay. But remember, the period is how long does it take to go through one cycle. So if there are 60 cycles in 1 second, I want to think about how long would it take to go through one cycle. So there'd be one cycle in 1/60th of a second. So that's telling me the period. So now I'm going to work backwards and find the frequency. So I know the formula for period is 2 pi divided by b, or sometimes we use b for frequency, sometimes we use the letter f. You can use either one, it doesn't matter. And I'm going to set that equal to what I know the period is. So 2 pi divided by the frequency equals 1/60. So if I were to cross multiply and solve there, I would get 120 pi equals my frequency. So the correct choice for the do now should have been choice 4. The frequency is 120 pi. Let's take a look at question number 1. Please take a minute to read through the question, pause the video, and write down the important information on the side of the page. Okay, so let's take a look at some of the things that you wrote down that you were able to figure out from this question. So one of the first things you should have been able to record was that there's a maximum of 13 feet and a minimum of 5 feet in the water in the wave pool. So that's really telling me my range. I'm going from 5 inclusive to 13 inclusive. If I know that the range is 5 to 13, I can find the midline. So remember the midline formula is the minimum value plus the maximum value divided by 2. So if I figure that out, I would get 9. So that's telling me really that my midline is y equals 9. In other words, my function had a vertical shift up 9. Once I know that my midline is y equals 9, then I can figure out the amplitude. So I want to think about the fact that my midline is 9. Here's my midline. And I'm going up to 13. So how many units are from 9 to 13? That would be 4. Or I could think about my lowest value, my min is a 5, and going to my midline of a 9, how many units is that? That's 4. Or I could use the formula for amplitude, which is 1/2 the maximum minus the minimum. Okay. Either of those methods would be fine, and you would come up with the amplitude being a 4. Okay. The last thing I want to try to figure out is the frequency, but I need to work backwards because I'm not giving that information in the question. What I am given is the wave generator pumps 6 waves per minute. So this is going to help me figure out the period. I'm not there yet, but I'm on my way. So, okay, 6 waves in 1 minute. So now I want to figure out if I had 1 wave, how long would that take? So that would take 1/6 of a minute. The thing is, when they asked me to graph the function, they said from 0 to 30 seconds. So I want to write this in terms of seconds instead. So I have 1 wave in 1/6 of a minute, which is correct, but I want to think about how many seconds that would be. So there are 60 seconds in a minute. So if I took 60 seconds and divided it by 6, I would get 1 wave every 10 seconds. So that's my period, 10 seconds. I'm just going to record that up here. So now I'm going to work backwards to find the frequency. So I know the period is 10 seconds, and I know the formula for period is 2 pi divided by the frequency. My frequency is 10 seconds, so I'm just going to put 10 over 1. And then I could cross multiply. So 2 pi equals 10 times f. You could have used the variable b also. Sometimes we use that to notate the frequency. And then when you divide by 10, you would get the frequency as 2 pi over 10, or if you reduce that, pi over 5. So there's my frequency. Okay, so now I need to write my sine function, and then I'm going to graph it. So if I want to write my equation, I'm going to say this is y equals, now I need my amplitude, which is a 4, my trig function, which is sine, my frequency, which is pi over 5, my x value, which they're telling me is a t in this case, and my vertical shift is up 9. So there's the equation of my function. Now I want to graph from 0 to 30 seconds. So I have to figure out how I'm going to set up my axes. So let's see, I'm going to make this a little bit bigger here. Drawing my y-axis. And then I'm going to draw my x-axis. Or in this case, my t-axis. Okay. So now when I'm graphing, I need to figure out how often I'm plotting a point. So I need to figure out what my critical value interval would be. So critical value interval is equal to the period divided by 4. So I'm going to go back up here. My period was 10 seconds, so 10 divided by 4 is the same thing as 5 over 2, or 2.5 seconds. So I should be plotting a point every 2.5 seconds, and I'm plotting from 0 to 30 seconds. So I'm going to start here on my x-axis or my t-axis right here at x value or t value of 0. And then this first tick mark is going to be 2.5 seconds, then 5 seconds, 7.5 seconds, 10 seconds, and so on. So each tick mark is going up by 2.5. You don't have to label every single tick mark with its value, but you should just make sure that each one is going up by 2.5. I'm not going to label every one because it's a little bit small to write here on the iPad. So I'll label every other one, but each one is representing 2.5. So if you wanted to, there, I can make it a little bit bigger. You could have said that this was 2.5, and this was a 7.5, 12.5, 17.5, 22.5, 27.5, and then 30. Now I want to figure out how to label my y-axis. So I want to think about my range. The lowest my function is going to go is 5, and the highest it's going to go is 13. So I'm going to look at my y-axis here, and I can go by one. So I'll label this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That should be plenty. So when I'm graphing, the first thing that I want to do is draw in my midline. So I'm going to go back to my work and I'm going to find what my midline value is. So let's see. Getting a little bit better, guys, with the iPad and the colors. Still not as good as you, but I am learning how to do it a little bit better. So each video I make, hopefully you see some more colors. Okay, so my midline is y equals 9. So I'm going to draw it in here. Okay, the next thing I'm going to do is think about how am I going to plot my graph. So I think I'll draw my graph in blue. And I'm talking about a sine curve. So I'm talking about sine. I always want to remember that sine starts at the midline. So here I am at a t-value of 0. I'm going to start by graphing my first point, and that's going to be at the midline. Then I want to think about the general shape of sine. So if I thought about sine, I'm just going to draw myself a quick sketch. If I were to graph the sine function, it starts at the midline, goes to the max, goes to the midline, min, midline. That's what a sine curve would look like with a positive leading coefficient. So my coefficient here is a positive 4 because I wrote my equation with a positive amplitude. So I'm going to say, okay, I'm going from the midline now to the max. My max was 13 here. So at 2.5 seconds, I'm going to count up to 13. Put a point. Then I'm going to go to 5, my next critical value, go back to the midline, and then go down to the min, which was 5. Then midline, max, midline, min, midline, max, midline, min, midline. Make this a little bit bigger and try to draw my curve. Nice and smooth. Connecting to every point. There we go. Now you might be thinking to yourself, well, could I have drawn my graph like this? Could I have said my equation was y equals -4 sine pi over 5t plus 9? And that is also correct because the question talked about the wave in the pool oscillating between a max of 13 and a min of 5, but they didn't say any more than that. So if you had written the equation y equals -4 sine pi over 5t plus 9 and graphed that, so when you graph that, if you had started at the midline and then made your first point at a time of 2.5, if you had made your first point at 5 and then continued to graph from there, that would have also received full credit.